everyone, welcome back to my channel Learn Math with Priya. We are continuing the real numbers of grade 10. So we are going to do some of the sums from exercise 1.1, and the first sum is based on fundamental theorem of arithmetic. If you have not watched my previous video on the same, please do click the link here. Okay, what is fundamental theorem of arithmetic? Every composite number, okay, all the composite numbers can be expressed or factorized as a product of prime. So I can express any composite number in terms of product of prime numbers. So this concept we are going to imply for the first sum. So the first sum, the subdivision 1 is 140, right? So I'm going to factorize 140. So you can do ladder method and using prime factors factorize it. So 2 times 7 is 14 and just bring the 0 down. Again, I know it is an even number. Either I can go with 2 or 5, right? So 2 or 5 both are prime numbers. So I can use 5 so that my factorization will be easier. So 5 ones are 5. The carryover will be 2, right? Because there is a 7 here. So 5 ones are 5. The remainder 2 will be carryover. So now it becomes 20. 5 times 4 is 20. Now it's an even number, so I can divide by a prime 2. 2 times 7 is 14. I can stop doing factorization. Now 140 can be written as 2 times 5 times 2 times 7, right? Suppose if I want to write it in ascending order, it is 2 times 2 into 5 times 7, right? Suppose if I want to write in terms of powers, because we have learned exponents, so we know how to write the number in terms of powers, right? So 2 into 2. So 2 is repeated how many times? 2 times, right? So it is 2 square into 5 into 7. So remember, any composite number can be expressed or factorized as a product of primes. Okay? So coming to Roman number 2 of question number 1, it is 156. So what is the first step? I have to do ladder method, and since the number is even, I can go with prime number 2. So 2 times 7 is 14 and the carryover will be 1. So now it becomes 16. So 2 times 8 is 16. Again it is a even number, so I can divide by 2. 2 times 3 is 6. The carryover will be 1. 2 times 9 is 18. Now 39. Okay, 39 is not an even number, but I know sum of the digit. 3 plus 9 gives me 12, right? So it comes in 3 table. So when the sum of the digit is divisible by 3, then I can go with the prime number 3 to divide it. So 3 ones are 3. 3 times 3 is 9. And 13 is a prime number, so I can stop doing factorization. So I can express 156 as the product of prime, which is 2 times 2 times 3 times 13, isn't it? So, what is 2 times 2? 2 is repeated 2 times, so I am writing in terms of exponent. 2 square times 3 times 13. So, understood? Any composite number can be written as a product of prime. So, that's what my question is. So I'm going to do ladder method. So I know the unit digit, that is ones place ends with 5. So definitely it is going to be divisible by 5, and I know 5 is a prime number, right? So 5 times 7 is 35, but I have 38 here. Okay, so the remainder is 3, isn't it? So it becomes 32. 5 times 6 is 30. Again the remainder is 2. So 5 times 5 is 25. Now again the unit digit ends with 5. So divided by 5. 5 ones are 5. The carryover is 2. 5 times 5 is 25. Again, the carryover is 1. So 5 times 3 is 15. Now, it is no longer divisible by 5 because the unit digit is 3 here, right? So I have to check the divisibility rule for 3. Sum of the digit. So 1 plus 5 plus 3 gives you 9. So I know it is divisible by 3. 3 5s are 15. 3 1s are 3. Okay, again sum of the digit gives you 6, so it will be divisible by 3. 3 times 1 is 3, the carryover will be 2, it becomes 21. 3 times 7 is 21, right? So now I am going to write the prime factors for 3825. The product of primes are just arranged in ascending order. There are two threes, so it is 3 times 3 and 5 times 5 and one more 17, right? So I have to write it in terms of powers. So it is 3 square into 5 square into 17. So this is my answer. Hope you also got the same answer, right? Good job. Now we are moving to the fourth sum. It is 5005, right? So I'm going to do the ladder method, and and I know I have to use prime number 5 to divide it. It is 1001, right? By now you are familiar with the prime factorization, isn't it? So now 1001, okay, which number I can go with? I know the first prime number is 2, but it is not an even number, so I cannot divisible by 2. And what is the divisibility rule for 3? Sum of the digits should be divisible by 3. So 1 plus 0 plus 0 plus 1 is 2. So I know that it will not appear in 3 tables. So it won't be divisible by 3. Then check for the next prime number 5. The unit digit is not 5, so it won't be divisible by 5. Then go for the next prime number 7. Okay, so when I divide 7, I think there is a possibility. So let us try. So 7 ones are 7. Here there is a number 10, so 3 will be carryover. 7 times 4 is 28. Again, there is a reminder 2. So the carryover is 20. So it becomes 21. So 7 times 3. Yes, it is perfectly divisible by 7, isn't it? Now check for the again which prime number I have to choose to divide it. It will not be divisible by 2 again. Okay, it will not be divisible by 3 because sum of the digit is 8. So it won't be divisible by 3. It won't be divisible by 5 either because the unit digit is not 5. And 7 also it won't be divisible because 7 times 2 is 14 and 3 will be a reminder. And the next prime number is going to be 11, right? And let me check, it is divisible by 11. Okay, 11 times 1 is 11 and 3 will be carryover, isn't it? And so 11 times 3 is 33. Yeah, so this is how you need to do the factorization. Okay, you have to choose the right number to divide it exact number of times. So 5005 is written as a product of prime 5 times 7 times 11 times 13. Got it? So come to the fifth sum, 7429. I'm going to divide again using prime factors. So sum of the digit, I know it is not an even number, so it won't be divided by 2. Let's go for sum of the digits. 7 plus 4 is 11, 11 plus 2 is 13, 13 plus 9 gives you 22. Again, it won't be divisible by 3. Let's go for 5. It won't be because the unit digit is not 5. Just try 7. Okay, when I try with 7 7 once the next number is less than the divisor, so I cannot divide the next number. So for that I have to insert 0 and combine with the third digit. Okay, so it is 7 times 6 is 42 and 7 times 1 again it leaves a reminder, so I cannot divide by 7. Do you understand? So I'm just doing trial and error method for you, right? So it won't be divisible by 7 as well. Now go for the next prime number 11. Okay, 11 times 6 is 66. So the remainder is going to be 8. 11 times 7 is 77. The remainder is going to be 5. Again, it won't be divisible by 11. So 11 also is not possible. Okay. So now we are going for 13. Okay. Let's try with 13. 13 times 5. Okay. What is 13 times 5? It is 65. So let me go for 13 times 6. Okay, it's 78. It's more, right? So I have to go for 13 fives are, which is 65. So the remainder will be 9, right? So 92 will go for one more. 7, 7 threes are 21. So it becomes 91. So it is 7 times. So 1 will be carryover. Again, it is not divisible by 13 as well. Okay, so I have to repeat only prime numbers, so I know till 13 it is not working. Okay, let me try for 17. Okay, the next prime number is 17. So let us see whether it is divisible by 17. 17 times 4, okay, it is going to be 68. What is 17 times 5? It is 85, right? So no, it is more, so I have to go only 4 times. So the remainder will be 6, right? So it becomes 62. So I can go for 3 times. Okay, so 17 times 3 will be 51. So the remainder will be 11, 119. So let's go for 17 times 7. 7 sevens are 49. Okay, 1 sevens are 7, 8, 9, 10, 11. So it is 119. It's perfectly divisible. Okay, do you understand how to choose the proper prime number to divide it? Sometimes it becomes tricky to find the prime number. Okay, now it becomes 437. Again, you have to start from the beginning. First, you check for even number. It's not an even number. Okay, go for 3. 4 plus 3 is 7. 7 plus 7 is 14. It won't be divisible by 3. It's not divisible by 5 as well. And how about 7? No. Okay. And how about 11? 11 will be divisible. 11 times 3 is 33, so 10 107. No, it won't be divisible. How about 13? So let's see whether it is divisible by 13. You can do long division method like this and check whether it is divisible by 13. 13 times 3 is 39. Okay, and the remainder is 4, right? So 47, and it won't be divisible by 13 as well. Now go for 17 again. 17, let me see whether it is divisible. 17 times 2 is 34, right? So 17 times 3 is 51. So I cannot go for 3. 17 times 2 is 34, and the remainder is 9. Yes, 97. Again, I don't think it is divisible. Let's go for some other prime number, 19. Okay, let me see whether it is divisible by 19. 19 times 2 is 38. Okay, the remainder is 5, right? Yeah, 57. So 19 times 3. 9 threes are 27. 2 1 times 3 is 3 plus 2 is 5. So yeah, it is divided by 19, right? So how many times it is? 19 times 2 is 38, and the remainder is 5. It becomes 57. So 19 times 3 is 20, 57, right? So 23 is a prime number, so I can stop doing the factorization. So see how tricky it is. Okay, it's not a, we are not using the smallest prime number now. The prime numbers which we selected are above 11, right? So it is 17 times 19 times 23. Okay, so this way you can find which prime number, you can select it to divide the number completely. Got it? So with this we are completing question number 1 from exercise 1.1. The next topic is HCF and LCM, and we are going to do some exercise sums as well from exercise 1.1. Let's meet in my next video for the continuation of the chapter real numbers. Thank you.